In the last video, I introduced the idea of the standard error, and I also gave you some visuals to help you start to understand the meaning of a standard error. In this video, I'm going to go into a little bit more detail about what a standard error is and why it's useful. So, a standard error tells you three things. Let's go over them one at a time. First, it tells you the amount of dispersion in the sampling distribution. This is something we talked about in the last video. If the standard error is small, then the sampling distribution has low dispersion. The boxes are close together. If the standard error is large, then the sampling distribution has high dispersion. The boxes are spread out more widely. Remember that the standard error is just the standard deviation of a sampling distribution. It's just a certain type of standard deviation. So if a sampling distribution um, doesn't have much dispersion to it, it's going to have a small standard deviation or a small standard error. And if a sampling distribution is highly spread out with high dispersion, it's going to have a big standard deviation, a big standard error. That's all there is to this first point. Second, it tells you how much sampling error is expected in a random sampling situation. And I'll give you a quick example of what I mean here. So if a sample mean is being calculated and the standard error is 5, then that's telling you that the sample mean is likely to be about 5 from the population mean, roughly, on either side. In other words, it's telling you that the sample mean is likely to be about 5 off target from the population mean. Um, Now, if the standard error is 5, it doesn't mean that the sample mean is definitely 5 from the population mean. It's just telling you that the sample mean is likely to be roughly that much from the population mean. So the standard error just gives you an estimate of roughly how much sampling error will happen in a certain random sampling situation. It might help if we break down the term standard error. So standard means typical or average, and error means inaccuracy. It's how far off target something is. So standard error is just typical inaccuracy. The standard error of a random sampling situation is just the typical inaccuracy of that situation. So if a random sampling situation has a small standard error, it's likely to be highly accurate. And if a random sampling situation has a big standard error, it's likely to be less accurate, basically. It might help you understand this second point better if I share an example of a situation that would have a small standard error and an example of a situation that would have a bigger standard error. So an example of a situation that would have a small standard error is a person taking a random sample of fifth graders, recording their ages, and calculating the mean age of that fifth grade sample. Now, I'm guessing that the mean age of all fifth graders in the population is about 10.5, right? Because fifth graders are usually about 10 or 11. And if someone went out and took a random sample of fifth graders, recorded their ages, and calculated the mean of that sample, that sample mean would probably be pretty close to 10.5. It might end up being 10.2, or it might end up being something like 10.8, depending on who actually ends up in the sample. But it's not going to be a really it's not going to be a number really far from 10.5. Um, it's not going to be a sample mean of, let's say, 18.5 or 2.7, right? Because you're not going to get a sample full of 2-year-old fifth graders or 18-year-old fifth graders. So the sample mean in that situation is likely to be really close to the population mean. So the standard error would be small. I'm guessing that the standard error might be about well, something less than 1, maybe 0.5, maybe 0.3, because um, the sample mean is probably likely to be about 0.3 from the population mean of fifth graders. Um, like I said, the sample mean might be 10.2, it might be 10.6, it might be 10.7. Um, so that's an example of a situation with a small standard error. Now let's talk about a situation that would have a big standard error. Um, imagine someone goes out and randomly selects 5 people from the Bay Area and records their 5 annual salaries. and then the person calculates the mean salary of the 5 people by adding and dividing by 5. Um, well, in that situation, this, it's likely that the sample mean will be pretty far from the population mean because, well, in other words, it's likely that the sample mean will be pretty far from the mean of the entire Bay Area because the sample mean is going to be highly dependent on who ends up in the sample, right? If the sample has 4 unemployed people who aren't making anything, the sample mean will be way low. And if the sample ends up with 4 or 5 billionaires, then the sample mean is going to go way high. So in that situation, it is likely that the sample mean will be pretty far from the mean of the entire Bay Area. So that situation would have a big standard error. I'm guessing that the standard error in that situation would be something in the thousands. So let's say that the standard error, let's imagine that it's 5,000 in that situation. Well, that means that the um, sample mean is likely to be roughly 5,000 away from the mean of the Bay Area on either side, which is definitely a bigger number than the standard error for fifth graders, like I talked about earlier, which was only about less than 1, right? So one thing that the standard error is affected by is the amount of dispersion or spread in the population. And you hopefully you're beginning to understand that based on the examples I just gave you. So in my fifth grade example, the population members were really similar to each other in age. They're all 10 or 11 years old, which means that the sample mean um, is likely to be pretty close to the population mean because the sample mean doesn't have much wiggle room to vary, right? And the I'm sorry, the annual salaries of people in the Bay Area have a lot more dispersion, which means that the sample mean um, has more room to go way low or go way high, depending on who ends up in the sample. So um, if the population members have low dispersion and they're highly similar, that gives you a smaller standard error. And if the population members are more varied and they have higher dispersion, that gives you a bigger standard error. One other thing that the standard error is affected by, other than the amount of dispersion in the population, is the sample size. So if you take a really small sample, you're going to have a bigger standard error. So as the sample size goes up, the standard error goes down. So um, if you randomly select, like I said, if you randomly select 5 people from the Bay Area and record their 5 incomes, the sample mean is likely to be far off from the mean of the Bay Area. It depends on who the 5 people happen to be. That's a big standard error. But if you randomly selected 1,000 people from the Bay Area and recorded their 1,000 incomes and calculated the mean of the 1,000 people, then the sample mean is likely to be much more accurate, or it's likely to be much closer to the mean of the entire Bay Area, because a few extreme incomes won't throw off the sample mean very much. If a few billionaires end up in that sample, it's like a drop in the bucket. The standard error would be smaller, and you'd be more likely to get a sample mean close to the population mean in that situation. So overall, um, when the standard error is smaller, when the population has less dispersion or the sample size is larger. So you'll have a smaller standard error, and you'll be more likely to get an accurate sample if you have low dispersion in the population or a big sample. And the amount of dispersion in the population is something that you can't control if you're doing a survey because the population is what it is. But what you can control is your sample size. So if you're doing a survey and you're calculating a sample mean to estimate something about a population, and you want to have a small standard error, and you want to be confident that your sample will be accurate, um, what you can do is just take a bigger random sample, and your standard error will go down, and you'll be more confident about having an accurate result. So that's pretty much all I have to say for point number 2. Point number 3 is saying that The standard error also tells you how much a sample statistic will vary from one sample to the next. So if the standard error is small, then a sample statistic won't vary much from one sample to the next. But if the standard error is large, then the sample statistic will vary more from one sample to the next. So let me just give a couple of examples to explain point number 3. Let's go back to that 5th grade example. Let's say that I randomly select 20 fifth graders. I record their 20 ages, and the 20 people have a mean age of 10.8. Then let's say I go out and I randomly select a different group of 20 fifth graders, and I do it again. I record their 20 ages, and I calculate the mean of the 20 people. Well, the sample mean isn't going to be change very much, right? It's going to be pretty close to what I got the first time, right? So if let's say that the first time it was 10.8, the second time it might be 10.4. So even though it's a new group of 20 people, the sample mean won't change very much. And if I went out and I took a third group of 20 fifth graders and calculated their mean age, it'll be pretty close to what I got the first 2 times. The sample mean isn't going to that sample mean isn't going to bounce around very much from one sample to the next. It might, if I kept repeating that process, it might go 10.8, 10.4, 10.5, 10.9, and bounce around just a little bit from one sample to the next because of that small standard error. But now let's say I go out and I select 5 people from the Bay Area, I record their 5 incomes, and I calculate the mean, like I said before, and I do it again with a new group of 5 people, and I do it again with a new group of 5 people. In that situation, the sample mean is going to bounce around pretty much a lot from one sample to the next because the first 5 people who might have a mean of 40,000, the next 5 people might have a mean of 80,000, the next 5 people might have a mean of 90,000, the next 5 might have a mean of 10,000, depending on which 5 happen to be chosen. So that situation, that Bay Area example has a bigger standard error, which means that the sample mean will bounce around more from one sample to the next if different random samples are selected.